Hi, everybody. It's Mrs. Mancuso, and we are going to start a new unit today. So the unit is called Redox Chemistry. And redox chemistry stands for a type of reaction, and RED is a reduction reaction, and OX is oxidation. So if you have a redox reaction, you have both reduction and oxidation. And what happens, reduction is when something gains electrons, and oxidation is when something loses electrons. So the number of electrons lost is going to be equal to the electrons gained. So basically, it's like they're passing them. So we need to start off by looking at oxidation numbers, because oxidation numbers are what tell us how many electrons, so like the number of electrons gained or lost. And I hope you recognize this name, oxidation numbers. We've actually talked about oxidation numbers before. When you look at a square on the periodic table, so like let's say I'm looking at calcium. Up here in the top right, that's its oxidation number. And so for calcium, it's a +2. So if I have just calcium here, calcium has no charge, so it has an oxidation number of 0. But when it's going to bond, so only when bonding, will it end up having a change in charge. So only when bonding, this calcium would like to lose 2 electrons. So that's what calcium would like to do. So that's why when we do our little crisscross, I would write Ca +2. That shows the oxidation state of calcium is +2. What is it willing to do when it is bonding? The positive tells me it's going to lose 2 negatives. So I'm going to put it with something negative. So chlorine, look up in the top right corner. So normally chlorine is 0, but right now it's going to be a -1 when it forms a bond. Whoops, that's a negative. All right, so when you crisscross, you would say, all right, I would need 1 calcium and I would need 2 chlorines. So CaCl2. And when I have the CaCl2, this was a +2, this was a -1. Those are the oxidation states or the oxidation numbers. So let's do a couple more. Let's say I have magnesium. If it's all by itself, it's a 0. But in a bond with chlorine, MgCl2, that 2 came from the magnesium. So when it's in a bond, magnesium's oxidation state is +2 and Cl's is a -1. All right, let's look at some more. What if I have Fe2O3? I know oxygen's was a -2 because that's what it has on the periodic table. The periodic table also shows you the ones that are most common. So is a chance that in nature it's going to do something different than you expect, but most of the time it tells you the most common ones there. So the 2 crosses back up here telling me that oxygen was a -2. And then if I only looked at the periodic table, I wouldn't be able to figure out the oxidation for iron because it has 2 choices. It could be a +2 or a +3, but all I have to do is look at the compound, and that tells me the 3 came from here. So the oxidation number of iron is a +3, and the oxidation number of oxygen is a -2. Let's do another one. Let's say I have TiO. Well, now it looks like they're both 1s, but I don't get confused by that because I know oxygen isn't normally a 1. So if oxygen is normally a -2, but that 2 canceled out, titanium must have been a +2. So that's what their oxidation states are. All right, now what happens when you have more than more than 2 elements in your compound? So like H2SO4. This is where you have to do a little bit of algebra. So I'm trying to find out what's the oxidation number of H, what's the oxidation number of S, and what's the oxidation number of O? Well, H at the beginning is most likely to be a positive one because it's over on the left side, and usually whatever we put on the left is our positive, and especially since I know oxygen is negative. So I'm actually going to set up and call S my X. That's my X that I have to solve for. I have 2 atoms of hydrogen and they're each a +1. So that means I have 2 plus X, whatever this is for my S. And then I have 4 -2. So 4 times -2 is -8. This should all add up to 0 because you'll notice if I go back here, all of these add up to 0. 2 positive 3's is a +6, and 3 -2's is a -6. So that comes out to 0. A +2 and a -2 comes out to 0. If you have a compound, the number of electrons gained and the number of electrons lost is equal. Here I have 1 magnesium, so that's 2, and then I have 2 -1, so that's -2. So it comes out to 0. So all of these have come out to 0, so I'm just going to set mine to come out to 0. And by doing that, I say -2, or -8 and a +2 would give me -6. So x minus 6 equals 0. And then go +6 plus 6, x equals 6. And so now I can go back up here and put a little +6 on there. And then I always encourage you, just go back and check and make sure it's right. So if I have 2 plus 1s, that's 2, plus 6, and then 4 times -2 is -8, and that comes out to 0. So perfect. Let's do a couple more of these just to practice. Let's do KMnO4. So I know that I want to find these 3. I know K is a +1. I go look on the periodic table, and the only thing that K can be is a +1. And O is a -2. So Mn will be my X. And I only have 1 K, so that's 1. Plus, I only have 1 Mn, so 1 X. Minus 8 equals 0. So that tells me this has to be a +7. All right, let's do another one. Let's do K2CR2O7. All right, I know this is a +1. I know this is a -2. Now I got to set up my formula. So I have 2 plus 1, so that's 2. Plus I have 2 x's. So I got to put plus 2x there. Minus 7 times 2 is 14. Okay, equals 0. So -14 plus 2 is 2x minus 12. And then I would go plus 12 plus 12, 2x equals 12. And then divided by 2, divided by 2. These would cancel out. X is equal to 6. And I go back up here and I put in the +6. And I can go ahead and check my work. 2 plus 1s is a 2, plus 6 times 2 is 12, minus 7 times 2 is 14, and it does come out to 0. All right, let's try another. AlPO4. Sorry, when I write it, I like to stretch them out so I have a little bit of room. There we go. I look up aluminum and it's a +3. I know oxygen is a -2, and I got to find P. So I have 1 Al, so that's 3. I only have 1 P, so I only have 1 X. 4 times 2 is 8. So -8 and 3 is 5. So that would be a 5. All right, let's do another. KNO3. So this is a +1. This is a -2. 1 plus x minus 6. Oh, this one's also a 5. All right, so if I'm going too quickly, definitely just slow me down and try some yourself. I will do, I'll do one more. I'll do one that looks a little, it looks a little harder, but just because it has a parentheses. Okay, so I do this one, and Al must be the 3, so this is a +3, which means my whole NO3 is a -1. Okay, I'm now going to separate that out. NO3 is a -1. So now I'm going to teach you how to do it when you have ions. So N and O, and I've got to set this equal to -1. So I know this is a -2, so X minus 6 is equal to -1. So this would have to be a +5. So I go back up here. This is a +5, and this is a -2, giving the whole NO3 a -1 overall. All right, let's do a couple more ions because ions are fun to do. PO4 with a -3, and you can go to table E and practice any of these because all of them are ions. So PO4, I want it to have a -3 charge. So I don't want it to have a 0. It's not a compound that balances out. It actually is an ion that has a charge. So I know this is going to be my -2. So I go X, because I just have one P, -8 is equal to -3. So I can just go +8 +8, X is equal to 5. So this would be a 5 here. Let's do another. ClO minus. This is weird because chlorine's over on the right side, so I'm not expecting it to be a positive, but in this case, it's going to be a positive. So I put my -2 on here. So I have X minus 2 is equal to -1. So I go +2, +2, X is equal to 1. So this will be a +1 charge here. All right, so I have a practice sheet to go along with this that has all sorts of these problems for you to do for practice. Now I'm going to move on to the second part of this. So the second part of this is identifying redox reactions. So we said before, in a redox reaction, I have to have something go down in oxidation number and gain electrons, and I have to have something go up in oxidation number and lose electrons. So let's just look at a reaction for a minute. So let's say I have Na, sodium, and I add it to hydrochloric acid, HCl. I know that the Na would now knock out the H and bond with the Cl, and Na is a +1 and Cl is a -1, so my formula would be NaCl, and then hydrogen would be all by itself, but it's diatomic, so I'd put a 2 there, which would make me have to balance this guy. So 2 H's here means I need 2 H's here. That's going to give me 2 Cl's, so I'm going to have to put a 2 there and a 2 there. Okay, so I've balanced my reaction. My next step is that I have to assign oxidation numbers to everybody. So Na is alone, so it's 0. H2 is alone, so it's 0. I like putting the zeros on first. I actually already did it over here with the +1 and the -1 because that's how I figured out the compound that would be formed in this reaction. So now I just go back to H and Cl, and H was a +1 and Cl was a -1. So in order for me to figure out if this reaction actually was a redox reaction or not, I have to see, is something being oxidized and is something being reduced? So again, if it's oxidized, it's losing electrons. If you lose a negative, you become more positive, so your oxidation number will go up. And if you are reduced, you are going to gain negatives. And if you gain negatives, your number will go down. So I look and I see, is there something whose number goes up? So, oh, I don't know how these moved. These belong over here. Sometimes my little stylus moves. There we go. Okay, so we look at everybody and we see that Na is going from a 0 to a +1. So that means it was oxidized. And H is going from a +1 down to a 0. So I'm going to put a big yes This is a redox reaction because one thing went up and one thing went down. And now I have a little saying that I like to do, oil rig. So oxidation is losing electrons, reduction is gaining electrons. So it just helps me remember it. And then I want you to think about this. The rig goes down into the earth. So like the giant machine that is going to pump the oil. The rig goes down into the earth and the oil comes up out of the earth. So it reminds me oxidation is going to be losing the electrons and the oxidation number will go up, and reduction is going to gain those negatives, which makes its number go down. So if you remember the oil rig, you will help remember, that saying will help you remember it and help you identify it. So now I want to show you another reaction, and let's say I have Fe plus MgO, and I form FeO. This was a +2 and this is a -2, and then Mg is all by itself. And I want to see if it's redox, so I assign oxidation numbers. You're alone, so you're a 0. You're alone, so you're a 0. O is a -2 and Mg is a +2. All right, oxidize, the oil comes up out of the ground. Rig gains the electrons and the rig goes down into the earth. Okay, so does somebody go up? Yes, Fe. Fe changes from a 0 to a +2, so it's oxidized. It's going to lose electrons. And reduced, who is reduced? So I look and I see Mg. Mg gets reduced. It goes from a +2 to a 0. All right, let's try another reaction. Let's say I have TiCl2 plus NiO, and you end up forming TiO plus NiCl2. All right, that's a double replacement reaction, whereas I should have pointed out the last two that I've done are a single replacement reaction. So let's go ahead and put everybody's charges on them. So this 2 crisscrosses up to the titanium, and Cl is a -1. I know O is a -2, so the nickel must have been a +2. Same thing here. I know this is a -2, so this would have to be a +2. And this is a +2 and a -1. So I want to see, did the oil come up and the rig go down? Is there something whose charge went up? Ti is +2 both times. Cl is -1 both times. Ni is +2 both times. O is -2. This is not a redox reaction. So double replacement reactions are not redox reactions ever because the charges don't change. But single replacement reactions always are. So let's do a single replacement reaction with a non-metal like oxygen. So if I have oxygen and salt, let's say, all right, the oxygen is going to go with the Na because Na is positive, so I would go with the Cl. Cl is negative. So I know Na is a +1 and O is a -2, so it would be Na2O. And then now my Cl is knocked out, and that's all by itself, but it's diatomic, so I put the little 2 after it. And to balance it out, I would need 2 of these. Oh no, I need more. Na2O. Okay, I'm going to need 2 of those. I'm going to need 4 of these. See, balancing is sometimes a little messy. So that'll give me 4 NAs, and it'll give me 2 O's. But now I have 4 Cl's, so I also have to put a 2 here. All right, just a good little balancing practice. I know Na is a +1 and Cl is a -1. Oxygen's alone, so it's 0. Cl is alone, so it's 0. So I want to see, is something oxidized? Does its oxidation number go up? And is something reduced? Its oxidation number goes down. So who goes up? Oh, let's see. Na stays the same. Oh, Cl goes up. So Cl changes from a -1 to a 0. So that's going up. And oxygen is getting reduced because it is going from a 0 to a -2. So yes, this is a redox reaction. So that is my lesson for today. Just a bunch of practice on how to figure out oxidation numbers and then how to be able to look at a reaction and see if it's redox or not. Oh, I know what. I wanted to do a decomposition or a synthesis reaction. So let's do decomposition. So let's start with, we'll just do an easy one. Let's start with salt. And I want to break salt down into sodium and chlorine. And again, it's diatomic, so that's why I had to put the 2 there. So I go back over here and put a 2 there, and that gives me 2 NAs. Okay, this is a 0. This is a 0 because they're alone. And this is a +1, and this is a -1. So I want to see, does something go up and does something go down? And if I do have something going up and something going down, I do have a redox reaction. So Na is going down. So Na is going from a +1 to a 0, and Cl is going up. It's going from a -1 up to a 0. So this is also a yes. So we know that double replacement reactions are always a no. They are not redox reactions, but I can just go through and do the work with anything else. Single replacement reactions are always going to be redox, and I can go through and check with any other reaction. I just got to make sure something's oxidized and something is reduced. All right, have a great week, everybody.